Alright guys, so we're gonna try something new. I'm gonna be in the video this time. That way you can see that I'm really interested in what I'm talking about, but maybe not. We'll see. You could probably also watch me struggle as I write on this thing, but that is also okay. So today we're talking about 4.4, which is graphing. We're gonna kind of put 4.1, 4.2, 4.3 kind of all together, where we talk about the, well, not necessarily the mean value theorem, but we talk about all the different concavity, increasing, decreasing, and max and mins from the derivative and the second derivative to determine what does our graph of our function look like. So remember, things we have to remember before we start on this one is going to be that, there we go. It's not working right now. Well, first off, let's talk about the first derivative. What's the first derivative going to tell us from last time's lesson? Now remember that we know that if the first derivative is positive, then that means that the function is increasing. If the first derivative is negative, then we know that the function is decreasing. And then we know if the second derivative is positive, that means that the derivative is increasing, which means that f of x is concave up. And if the f double derivative is negative, oops, I have two errors on this one instead of equal sign, then that means that my function is concave down. There we go, getting better with this. So let's look at what can we determine from all of these awesome things right here. So here's an example that they give us in the book. And it's just saying, hey, given the following information about the first and second derivative, find a function f that is continuous on negative infinity to infinity and summarize the information using a sign graph. The sign graph is not necessarily super important, but we're going to kind of lay it out here. So what I like to do when they give us these points is we're going to say, okay, well, we have these intervals. Here we go. Let's go to black. We have these intervals right here, negative infinity to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to infinity. So I'm going to kind of just lay it out here. Negative infinity to positive infinity. And I have to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to infinity. There we go. So I look at this right here and it says, okay, my derivative is less than 0. I come over here. If my derivative is negative, then I know my function's decreasing. So I'm going to say decreasing right here. And I know my derivative, second derivative, is positive. Well, second derivative is positive, then it's concave up. So I know it's decreasing and concave up. What does a decreasing concave up something look like? Kind of like this. So my graph is increasing from really negative to less negative, so that's increasing, which means it's concave up, but it's a decreasing f of x value. Okay, I'm going to look at the next one right here from 0 to 1. They're both positive, right? So my function's positive right here, my derivative is positive, and my second derivative is positive. Well, positive means increasing, and this means concave up. So this one's going to be on this one. Where are we at? It's still concave up, but it's increasing. which is going to look something like this. Okay, then I know that right here, f prime is greater than 0 and f double prime is less than 0. So if the derivative, I have it as increasing and concave down. So the derivative is positive, so that makes it increasing, and the second derivative is negative, which makes it concave down. And it still is increasing. Okay, so if it goes decreasing to increasing, I know, hey, look, that's going to be a decreasing to increasing. That's going to be a minimum. But this is going increasing to increasing. So it's kind of going to look something like this, which this is increasing. That's still increasing. There's no extrema right here, but it's going from concave up to concave down. So I know it's going to be an inflection point. Okay, so let's go to the next one, from 2 to 3, both negative. So I know that's decreasing and concave down. Looks something like this, which you can see increasing to decreasing. That's going to be a maximum. And then 3 to 4, it's decreasing because f prime of x is less than 0. And it's concave up because my second derivative is positive. Do we have a decreasing concave up? Yep, just like that. So this one looks just like that one. And then this one's saying, hey, look, it's positive for both, which is going to be increasing and concave up. Now, obviously, my graph just doesn't look like this all the way through and through. I'm like, okay, well, here's what I know. I'm going to have a minimum, maximum, minimum, point of inflection, and then as this one goes on to infinity, this one's going to be increasing concave up forever. And this one's going to be concave up and decreasing forever, right? So if I go to this graph, I want to kind of sketch this graph. Okay, so I have 0, 1, 2, 3, 4, okay. So I know I'm going to have extrema at 0, 2, and 4. So it's going to be a minimum. So I can do something like this. A minimum at 0. Change my inflection. A maximum at 2. Change my inflection point. Minimum there. Something like this. Notice that this is a minimum. So this is a min. Right here, when x equals 1, that's an inflection point. Oh, thank you. And then this one right here is a maximum. This one right here is an inflection point. Minimum. And then increasing and decreasing forever. So the graph looks something like that. Now, I can't pick out the exact y values from the information that's given. That's not what it's asking for. It says find a graph, a possible graph of f. Boom, that's a possible graph of f. So we can determine a lot from these. Now look how much information we got just from the first derivative and the second derivative, where it's increasing, where it's decreasing, where we have these points. So when you have to graph something, then you're going to want to find the first derivative, you're going to want to find the second derivative, you're going to want to find where those derivatives are 0. You're going to want to find where they're positive and where they're negative and find these intervals. So this is the kind of information that you're going to want to get if you're just given an equation that looks just like, I don't know, x squared minus 400x or something like that. I think it's, x to the third or something crazy, or I think it's x to the third minus 400x that you're going to have to do in class. So the book kind of gives us these like, here's some general graphing guidelines, which, it's good, but if you like, I have to proceduralize this, then don't do this. But there's some things to be cautious of. Like it says, exploit symmetry. Well, yes, but knowing whether it's even or odd usually for me comes after I've graphed it, to be honest with you. I never used it to graph, but if it helps you, great. So this says identify the domain or interval of interest. So if only, like for us, it wants us to find it from negative infinity to infinity. That's why we did that. Sometimes they'll want you just to graph for a little bit. Okay, find the first and second derivatives. It gives you a ton of information. Concavity, inflection points, extreme maxes and minimums, increasing, decreasing. So that is just going to be crucial. The critical points and inflection points, remember that's where the derivative is zero or undefined and where the second derivative is zero or undefined. Find out where they're increasing or decreasing, extreme values, locate all asymptotes and end behavior, find the intercepts if you can, like if you have a graph, and then choose an appropriate graphing window, which, that just makes sure you have it. Um, this becomes a little bit um, less important because of graphing calculators and because of Desmos and because of different things that have the capability to just say, hey, look, here's what it is. I'm sure we could type something into AI that says, hey, I want you to do this for me, and it will give you a possible graph. So, but understanding these kinds of things will help us to do like related rates or optimization problems or things that we're going to be doing in the future. So it's good practice. It's good to know what the derivative is telling us, and the second derivative and the relationship between these things is going to be very important. So good luck on your classwork and those problem sets, and I will see you guys next time.